Take a look at solving this log equation where I've got logs on both sides and I end up with a quadratic answer. So first of all, I notice I have two logs on the left side, so that means that I want to condense things first. When I am adding, I know I switch to multiplication. So I have log base 9 of x minus 10 times x minus 4 equals log base 9 of 55. Because these logs, there's one log on each side, we know that their insides are equal, which we effectively say we cancel those. So I have x minus 10 times x minus 4 equals 55. Now, I know my instincts for algebra tell me I need to FOIL this here. So I'm going to go x times x is x squared. X times negative 4 is negative 4x. Negative 10 times x is negative 10x. Negative 10 times negative 4 is positive 40 equals 55. Now I'm going to do a couple of things at once. I'm going to combine these like terms together. So we get x squared equals negative 14x. And then at the same time, I know if I've got a quadratic, because I've got a squared there, I got to move this 55 to the other side to get it equal to 0. So when I move that 55 over 40 minus 55 is negative 15 equals 0. I now know I'm going to use factor that with a magic x. So two numbers multiply to 15 and add to negative 14 would be negative 15 and positive 1. I don't have a leading coefficient, so I can just write, x minus 15 times x plus 1 equals 0. I'm going to use the zero product property to make sure that these are both set equal to 0. And then I'm going to solve. So x equals, I'm going to add the 15, positive 15. I'm going to subtract the 1, so x equals negative 1. And now I need to check my answers into the original and make sure I don't get a negative inside. So if I'm taking this 15 and I put it in here, it's positive. If I take this 15 and put it in there, I know it's also positive. So 15 is a good answer. I'm now going to check the negative 1. Ooh, negative 1 and negative 10 is a negative answer, so that one is extraneous and is not a solution.